Okay, welcome to lecture 4.5. All right, now, just gave you some of the definitions of the independent variables in the McFadden paper. Okay, next, okay, the next thing, the loss of money was actually, I'm going to say loss because we're converting money into the consumer goods. So loss in terms of loaves of bread, loss um, from paying CI for um, transportation um, mode transportation mode I, and this equals alpha 1 plus CI divided by PF. Okay. Uh, now, the idea is that this is the loss from having to pay the fare, the bus fare, cab fare, BART fare. You pay CI in the fare, divide that by the price of the consumer good, and this tells you the loss in terms of loaves of bread for having to pay that BART fare or bus fare, cab fare. McFadden adds a constant, alpha 1, and for life of me, I don't quite understand why you'd put a constant in there. The best I can think of is suppose you pay by check and you write a check, and so what's the total cost of a check? Well, at my bank, I pay something like, it's kind of expensive. To order new checks, it's like 30 cents per check. I'm paying something. So the alpha 1 is that 30 cents that I'm paying. If I'm paying bus fare, or you could say, if I'm paying bus fare, take some time to take out your wallet and pay the money. That 60 seconds of time is worth some cost to you. That's the only thing I can think of to justify that alpha 1. Later, he's going to say we can't identify. He's going to have an alpha 1 and an alpha 2, and he's going to say we can't identify them all. We're going to assume the sum equals A, and so it really doesn't matter that much. He introduces it, then later he's just going to kind of wave his hands and say, oh, forget about it. Okay. So anyway, we got that. This is equation 1. Okay. Okay, next. Next. Opportunity cost of lost wages from traveling for TVI. I don't think McFadden actually gives the unit of time he's thinking of when he talks about TVI. Let's call it minutes. We're traveling TVI minutes on mode I. Okay, so if I'm going to make TVI in terms of minutes, the units are minutes, I'm going to have to say the wage is also in terms of minutes, okay? But this equals alpha 2 plus PW times TVI. So that is like the lost dollars. So you multiply your wage times the number of minutes. Okay, that's the lost dollars from having to spend 13 minutes on the bus, like my son does. Now we'll divide this by the price of a consumer good. So we're going to convert the dollars into loaves of bread. Okay, so P divided by PF. Okay. Next, um, yes, the opportunity cost of. Oh, and by the way, so again, that alpha 2, I'm not sure why. Um, why you have that alpha 2. So I don't know. Like, for some reason, um, you, you have to go to work. I don't know, maybe that's the cost of time. I guess you gotta you gotta get dressed and take a shower. Who knows what that means? There's some extra amount of time that we convert into loaves of bread for having to go to work. So I'm not sure how to justify that alpha 2. Okay, Fadden puts it in there though. Opportunity cost of um, lost wages from waiting a sub I minutes for mode I. Okay, now I put waiting, but I told you if it's my son, that when I said waiting, it actually also includes the walk to the bus stop. So 2-minute walk to the bus stop plus 4-minute on average wait. That's the TAI. The opportunity cost from that, um, McFadden assumes, is T sub A sub I times your wage. Okay, you're wasting TAI minutes, multiply that by your wage, PW, divide that. We're going to convert that into loaves of bread. So divide that by um, uh, the price factor. Um, um, and then, again, I don't have a good justification of this. McFadden multiplies that by alpha 3. Okay. He doesn't have a similar term here. Okay. The only way I can justify this is to think, well, okay, if this is the time that you're on BART, um, maybe it's easier to read on BART. So, whereas you can't read when you're waiting while you're walking to the bus stop, if that's true, that alpha 3 should be greater than 1. On the other hand, maybe what he's thinking, because this could also be car. You can't read if you're driving your own car. You can't read on the way to the car. So maybe in that wait to the bus stop, you're walking and you're getting some use out of walking. If that's true, the alpha 3 should be less than 1. So it's more useful for your time to walk than just sit in a car. Who knows? But anyway, he has alpha 3 times that amount. And then what he does is, okay, total loss uh, total loss from travel and access time. So it just equals this plus this. And so we get alpha 2 plus P W TVI divided by P sub F. By the way, I'm going to try to separate this out. Remember, the TVI is an independent variable, so that will be observed. This alpha 2 and this PW. Oh, wait, let's see. No, those may be. No, I think, no, he's going to know those too. So he's going to ask in the survey, he's going to ask things like the consumer, what's your wage? And so that's going to be PW. So if you like, put a superscript J on lots of these independent variables. They refer to consumer J. So all of this analysis, I'm applying it just to one consumer, so I'm dropping the superscript J. alpha 2 plus PDI plus alpha 3. I'm going to switch the order a little bit just so it's consistent with this. PW divided by PF times TA sub I. And this is equation 2 in McFadden. Okay, then finally, loss from discomfort. And that just equals K sub I. And that is equation 3. Okay. All right, now, okay. There's some choices he makes that I think he didn't need to make. That makes it a little more complicated than it needs to be. But I'm going to follow what McFadden does. Okay, and here's what he does. He next assumes that the total loss to consumer J from mode I equals A plus theta 1 times equation 1 plus theta, what did he do? Theta 2 plus equation 2 plus, okay, he's going to define a theta 3 later. Okay, so I'm going to skip theta 3. I'm going to just put, as McFadden does, theta 4 times 3. Okay. So he adds some extra parameters that he's going to multiply those loss terms by. Okay. And then once we do that, we get, it equals, so I'm just going to use this equation and substitute in from all of these 3 equations, 1, 2, and 3. Okay, that's all I'm doing. And here's what we get. Okay, we get A plus theta 1 alpha 1 okay, plus theta 2 times alpha, wait, plus theta 1 times 1 times C I divided by P F. Okay. Theta 1. Okay. Plus theta 2 times alpha 2 plus theta 2 times PW divided by PF times TVI. Okay. Plus theta 2 times alpha 3 times PW divided by PF times TA sub I plus theta 4 times ki. All right. Okay. Now, what he next does is he says, oh, and by the way, so notice everything I've put in parentheses equals independent variables. Okay, so we'll get CI, PF, PW, TAI. We will get all those from those surveys. Okay, so those will be things, those are data. So all we got to do is get those data for consumer J, take his CI, what's the cost for mode I, divide it by the PF, price. That's the price of a consumer good. So wherever that person lives, the inflation index for the county that person lives in. But all these things are observable, and we can just put a number on those, we the researcher. So all these things in parentheses are going to be independent variables. And so we're multiplying it by a parameter. So what we're going to do, it's going to be like a regression. Okay, it's going to be more complicated than a regression, but it's like we're going to have a parameter times that independent variable, different parameter theta 2 times that independent variable, and then a different parameter theta 2 times alpha 3 times that one. Okay, let's talk about this term right here first. It turns out we're going to have an identification problem here. The idea is that suppose that you found that theta 2 equals 2 and alpha 3 equals 3, okay? So the product of those is 6. If instead you divided theta 2 by some constant and you multiply alpha 3 by that same constant, their product is going to be the same. So, that when I say the constant, say that constant's 1.5. So before we had 2 and 3, multiply 2 by 1.5, you get 3, but then divide 3 by 1.5, you get 2. Anyway, that product is going to remain 6 as long as you multiply theta 2 by a constant and then divide alpha 3 by that constant. The product of those two has got to be the same. And so McFadden says we can't identify theta 2 and alpha 3. We can only identify the product. And so what McFadden does is he just says, let's define theta 3 just equals theta 2 times alpha 3. Okay, so we're going to estimate theta 3. That theta 3 equals theta 2 times alpha 3, but we can't tell you what the particular values of theta 2 and alpha 3 are, only their product. Okay. We are going to have a similar problem with these three terms. Okay. A theta 1 times alpha and theta 2 times alpha 2. So, McFadden just defines A equals A plus theta 1 times alpha 1 plus theta 2 times alpha 2. Even if we knew theta 1 and theta 2, say from, multiplying, their parameters multiplied by those independent variables, even if we knew those, we can, suppose we could estimate even if we knew theta 1 and theta 2, we can always change A, alpha 1 and alpha 2 to keep this sum the same. So in other words, if I told you A equals 6, theta 1 equals 1, alpha 2 equals 2, theta 2 equals 2, and alpha 2 equals 4. If I told you those were the estimates of A, alpha 1 and alpha 2, I can always give a new value. I'm not going to explain this well. And that's, well, let's see, that sum is 6 plus 2 plus 8, 16. Okay. I can always, you told me A is 6, alpha 1 is 2, alpha 2 is 4. I can always pick a new values for A, alpha 1, and alpha 2 to make that sum 16. Okay. So if we know that the sum is 16, we can always change the values of A, alpha 1, and alpha 2. Um, what that means, I'm not explaining this well, we can identify the sum of those, but we can't identify the individual values of A, alpha 1, and alpha 2. So McFadden, what he does is he just says we'll define A equals A plus theta 1 plus alpha 1, theta 1 times alpha 1 plus theta 2 times alpha 2. And what we get is total loss for mode I just equals A plus theta 1 Ci divided by PF plus theta 3. No. Sorry. Theta 2 times this. PW divided by PF. PF times TVI plus theta 3 times PW divided by PF times TAI plus theta 4 times KI. Okay. Times KI. So that is the total loss. All right. Okay. I'm going to end there. It's taking 22 minutes. So now, think of this. Here's where I'm going to go. In the next little sub lecture, I'm going to say, well, okay, the consumer picks mode. Which mode does the consumer pick? Well, he picks, or she picks the one that minimizes this. So for each different mode, for BART, bus, cab, car, we'll have a different value for the independent variable. That CI, the fare is different for each one. TVI, the length of time you're going to have to spend on that mode. So we're looking at one consumer J, but we can look at the 6 different modes of transportation that he's choosing from. That's the different I's. We can fill, assuming if we knew the A, theta 1, theta 2, theta 3, theta 4, and the KI, that's going to be a random variable we don't know. But if we knew all those things, we'd say, look, we just plug those in and we can predict perfectly which mode of transportation that consumer is going to pick. Here's where we're going. We're going to say we don't know this KI. That is a random variable. That's a comfort level. So this is a random utility model. The consumer knows it, okay? Person J knows that, but we, the researcher, don't know it. We'll talk about the distribution of this. If we know that, we can talk about the probability that if we could plug in all the values for the parameters, we could state the probability that that consumer will choose mode I, whether it's bus or bus, cab, and so on. Once we can do that, once we can state the probability of observing which mode he chose, Then we've got that recipe. That's the first step in our recipe toward creating a likelihood function. And once we can do that, we can eventually maximize the likelihood function, and that will allow us to estimate these parameters: A, theta 1, theta 2, and theta 3. By the way, we're going to do a trick to get rid of that theta 4. We'll talk about that in a second. Okay. All right. So that is the total loss, and then I'll discuss a little bit more how to set this up in a likelihood function. I'll do that on the next lecture. Okay. See you there.